Hello, I had a question on number 10 in 5.5. So this one goes, a person standing close to the edge on top of a 48-foot building throws a ball vertically upward. The quadratic function, this thing right here, models the ball height above the ground, h of t in feet, t seconds after it's thrown. And we're asked to find the maximum height of the ball and then how long until it hits the ground. So even though this doesn't call for a graph, man, this makes so much more sense if you actually kind of look at a picture of what's going on. So we're finding this function h of t, so that's height as a function of time. So just to kind of point at this, I labeled my graph, here's my h, that's we're getting out height, we're putting in time. So what we're seeing here at the y-intercept, so this would be t equals 0, and you can see at t equals 0, the ball is 48 feet above ground level, and that's because we're at the edge of a 48-foot building and they have this little 48-foot offset on the formula. So that's t equals 0, we're starting at 48 feet. What's the maximum height of the ball? That's here, but you do have to be careful to find height and not time. So that's why kind of thinking of which one is which is really important. So t, we're putting in time, we're getting out height. So to find this 1.625 value, we're going to do negative b over 2a here. So we'll do negative 52 over 2 times negative 16, and that would get us this value. And then to get the 90.25, we're going to take that t that we found, this 1.625, plugging that back into the formula because that's giving us h, and notice it's asking for h and not t. So I think that was probably part of the problem for you. And then the second thing is how many seconds. Okay, so now it's asking for t, so that's going to be an x value. H is going to be a y value, t is going to be x value. So how many seconds does it take until the ball hits the ground again? So again, if you think about what that looks like in terms of the graph, that's an x-intercept because the y value is 0 when it hits the ground. So if we set this thing equal to 0 and then solve that out, we'll get a intercept over here at negative 0.75 that is not meaningful because it's where the parabola would kind of travel backwards in time through the buildings. That's not useful. But then we find this one out here also. So that's where it comes in contact with the ground. Hopefully this visual helps. So if we're finding maxes or mins also, that's going to be quadratic formula. So, I'm sorry, if we're finding maxes and mins, I said that backwards, that's going to be vertex. If we're finding how long until something hits the ground, that's going to be x-intercepts, which is going to be factoring our quadratic formula. So x's we find with quadratic formula or factoring. Vertex we use vertex formula, and always goes with maxes and mins. Hopefully that helps a little bit.